Okay, now in today's class, we just discuss about the arithmetic instruction. Okay, arithmetic instruction set. So the general mnemonic, I said already, the mnemonic is nothing but it's the general instruction format. Or the instruction is otherwise said to be a mnemonic. Instruction is otherwise said to be a mnemonic. The mnemonics of your arithmetic instructions are increment, decrement, add, add carry, and add code memory. Sorry, add with carry. I'm sorry, add with carry, subtract with carry, multiply, division, and decimal adjust accumulator. Am I audible?
Yes, ma'am.
Yeah. So, and this is your program status word register. It's an 8-bit register. We have discussed this in the last class. The C represents your carry flag. AC represents your auxiliary carry flag. FO is reserved for future use. RS1 and RS0 are used for selecting the register banks, and OC is your sorry, it is not OC, it's overflow flag. It's overflow flag. This is overflow flag, and this is also reserved for future use, and this is your parity flag. And coming to your instruction set, arithmetic instruction says the most affected flags are carry, overflow, and the auxiliary carry that we will discuss shortly. And the general format of the instruction, namely the increment and the decrement instructions. Increment and the decrement instruction will increment the data in a register or in a memory location by 1. For example, if I am telling this increment, assume that the accumulator is having 0.5H. The accumulator is having 0.5H. If I am doing INCA, it means that the whatever content that is being placed in the accumulator, that will be incremented by 1. So now after execution of this instruction, instead of 0.5, I will be having 0.6. Is it clear? Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. So now coming to your instruction set, the next the format, the general format. What are all the general format for the increment instructions that we have? If I'm telling increment A, what type of addressing mode is this? What type of addressing mode is this? What is said to be addressing mode?
Indirect.
Come again. What is said to be addressing mode? Any answers, guys? Any answers? Addressing mode is nothing but the way in which we are going to access the data. That is said to be addressing mode. Where the data is placed, either in a memory location or in a register. How you are going to access? Either directly you can access, or indirectly the address, if it is specified in a data. If the address is specified in the data pointer, that is said to be indirect addressing mode. Or if the data is placed immediately, that is said to be immediate addressing mode. We have discussed about these addressing mode, the 4 type of addressing mode, namely immediate addressing mode and register addressing mode, direct addressing mode, and indirect addressing mode. And in the increment and the decrement instruction, there is no immediate addressing mode, because you are going to increment the content by 1. You are going to increment the content by 1, only 1. So you are not having any immediate addressing mode. And now tell me, what is this increment A? What type of addressing mode is this? I need an answer. What is register? What is
Direct.
what is this A? It's a register, right? INCA will be a
Register.
register addressing mode. And INCRR, what is this RR? It is also a register that is available in the register bank. So what type of addressing mode?
Register.
Register. And increment your ADD means address, a memory address. What type of addressing mode? You are directly specifying the address of the data. So what type of addressing mode?
Direct.
Direct. And what is this? At the rate of RP. It is nothing but a data pointer. It is going to point out the address of the data. So what type of addressing mode?
Indirect.
Indirect.
Indirect. Increment DPTR. DPTR is a 16-bit address. Okay, it is, sorry, 16-bit register. I'm sorry, it is a 16-bit register. So you are going to increment the content of DPTR, the 16-bit content by 1. Okay. So similarly, if you can even match up with increment A and decrement A, increment RR and decrement RR, increment the content in the particular address, increment the data as pointed out by the address in the RP. There is no decrement DPTR. There is no decrement DPTR in your 8051. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now, so I have moved the content. Could you able to see the keil window?
No, ma'am. No, ma'am.
Oh, yeah. Please wait. I haven't shared the screen. I have. mm, Now,
Yes, ma'am.
Yes, ma'am.
okay. So what I have moved, I have used move instruction. See, move A comma 64H, move B comma 32H. I'm using INCA. I'm using INCA, and later, and then I'm using SUBB. Now, as of now, I'll use INCA. Okay. I'm going to use the instructions. I increment instruction. Okay. So let me run. So after execution, now let me do. After executing the program, we will be getting 65H in the accumulator. We will see the next program. Okay. So how to transfer data into the memory. Okay. Into the memory. Where 04 is the 63. Is that fine?
Yes, ma'am.
Okay. So next thing is about your addition instruction. So addition for single byte instruction and addition for multi-byte instruction. Sometimes if I need to add a multi-byte number, a carry will be generated. So we should not ignore carry while doing subsequent additions. So what we have to do is, there is a separate instruction set. We need to use that instruction while we are using multi-byte addition. So the general format of the addition instruction is add a comma and immediate data. So this comes under immediate addressing mode, and add okay. So add the content of accumulator and the register. So register addressing mode. Add the content of A and the content in the address. So direct addressing mode. Add the content A and the content as pointed out by the data pointer. So this is indirect addressing mode. So similarly for multi-byte addition, you'll be having one more variable here, that is add C, add with the carry. That is the meaning, add with carry. So what are all the flags that will be affected for your addition and the multi-byte addition in general are your carry flag, auxiliary carry flag, and the overflow flag. Okay, carry flag, auxiliary carry flag, and the overflow flag. And now So carry flag, for example, you can add up to two 8-bit numbers, right? You can add two 8-bit number. If after addition, if you are having a ninth bit, okay, if you are having a ninth bit, then, okay, if you are having a ninth bit, then a carry flag will be generated. Let me add two numbers, okay? Let me add two numbers. And these numbers are of two types. Either it can be a signed number or it can be an unsigned number. Okay. Let me begin with the unsigned number first. So this signed number, it is again two type. Either it can be a like sign. You will be having a like sign, or you may have a unlike sign. You may have a unlike sign. So let me start with unsigned, and the some of the problems I'll give it as an exercise. You can try it out. So now 5FH, I'm going to add with BDH. Okay. So the equivalent binary. So 5 is 0, 1, 0, 1, and F is 1, 1, 1, and 1. And B is 1, 0, 1, 1. And D is 1101. Okay. So now if I add these two numbers, okay, if I add these two numbers, so we know that 1 plus 1 is 0 and 1, and 0 and 1, 1 and 1, because we are adding three ones. Remember your full adder. So 1 and 1 over here, 1 and 1 over here, 0 and 1 over here, 0 and 1, and 0 and 1. So if you look this, you have a ninth bit. You have a ninth bit. This is a carry. This is a carry. Okay. And you have a carry from the lower nibble to the upper nibble. Lower nibble to the upper nibble, you have a carry. So you have your auxiliary carry. You have an auxiliary carry. Okay. And now coming to your overflow flag. There is a rule for the overflow flag. If you have a carry out, because this is a carry out from 0, 1 to third bit. From third bit to fourth bit, you have a carry out. For addition, it's a carry out. Okay. So carry, if you have a carry out from C6 to C7, okay. If you have a carry from C6 to C7, if there is a carry out to C6 to C out. So 0, 1, 2, 3, 4, 5, 6. From C6 to C7, if you have a carry out. And similarly, if you have a carry out from C7 to your carry, that is C8. Getting me? This is
Yes,
your
ma'am.
carry. This is your carry flag actually. Okay. If you have a carry out from C6 to C7 and from C7 to C8 and from C7 to C8, what you need to do is overflow flag is nothing but C7 XOR with C6, meaning carry, both the carry you need to XOR. What is C7 now? From C7 to C8 it is 1, and from C6 to C7 it is 1. So what is your XOR of 1 and 1 value? XOR of 1 and 1 value? XOR gate. When you will have 1? For like numbers or unlike numbers? Do you remember the truth table of XOR? So for like numbers, your XOR will be 0. Your overflow flag will be 0. Overflow flag is 0. Your carry flag is 1. And your auxiliary carry should be 1. And if you look at this number fully, okay, if you look at this number fully, how many number of ones you have? 3 number of ones we have. We have 3 number of ones. It's an odd number. Ones in the result. Hence, your parity flag will also be set to 1. Okay. Your parity flag will also be set to 1. Now,